Well, dear students, there is a question here on the board regarding Doppler effect. These questions are on the here in this video. Question will be on the Doppler effect. A stationary source emit the sound of frequency 492 Hz. The sound is reflected by a large car approaching the source with the speed of 2 meters per second. The reflected sound is received by the source and superimposed with a signal. What will be the beat frequency of resulting signal? Speed of sound 330 meters per second. So here question is important and I have to done such question many times. The source at rest means V as 0, but observer is coming. The car is moving toward this V, suppose VO. So for the sound coming to this, or observer moving opposite to sound. So frequency received, frequency of sound received by moving car and that is equal to n into C plus VO upon C. Here plus sign is there because sound going this way and observer coming this way. Now this n dash is reflected. Now the car, the moving car, sends sound sound of frequency n dash and the source become observer, becomes stationary observer. Observer. Therefore, the frequency of sound heard by source n double dash equal to n dash into C upon C minus Vs. Here now source moving in the direction of sound. Putting this value of n here, we get n dash n into C plus VO upon C into C upon C minus Vs. This C cancel. So n double dash n given is 492. C 330 plus 2 upon 330 minus 2. If we solve it, 492 332 upon 328 28. If we divide this, we get here this frequency will come out 498. First, the source frequency was 492. So difference of frequency is equal to beat frequency, and beats frequency 498 minus 496 means 6 beats per second. will be heard. This is question here, a good question. Actually, in such questions are generally asked in competitive exam. This question has been asked in JEE Advance. JEE Advance पूछा गया है in 2017. So, 100% in every exam, question will be on Doppler effect in every exam, competitive exam. So, please do it properly. Well, yes, and now there is another question here. A good question has been asked in competitive exam JEE in 2010. Doppler effect again. A stationary source is emitting sound of frequency at a fixed frequency n0. n0 is the fixed frequency of sound emitted by a source, which is at rest, which is reflected by two cars approaching the source. The difference between the frequencies of sound reflected from the cars is 1.2% of n0. What is the difference between the frequency, between the speed of sound, speed of two cars, two nearest integer. Speeds of car is much smaller than that, than the speed of sound. Speed of sound 330. The solution is very simple, the same as previous question. Here is the source. Two cars are moving this way. Let their speed be V1 and V2. Sound is going this way. The frequency received by this source itself, just now I have proved. N dash first received by this car will be N into C plus B upon C. This N dash reflected, so N double dash will be N dash into C upon C. Now it becomes source Vs. So that way, if this is V1, in place of Vs, Vo is V1. This is V1, so N double dash become equal to N into C plus V1 upon C minus V1. Similarly, it is for car 1, it is car 1, it is car 2. For car 2 we can write N2 double dash equal to N into C plus V2 upon C minus V1. Now N1 dash minus N2 dash, N common, N is equal to N0 here. Yes, this N is equal to N0 here. So it will be C plus V1 upon C minus V1 minus this N0 common, C plus V2 upon, V2, C minus V2. This difference 1.2% of N0. I will take it later on. मैं इसको रब करता हूँ. N dash N1 double dash minus N2 double dash 1.2 upon 100 of N0, यानी कि 0.012 N0 equal to N0 into, I can write this thing as C plus V1 into C C minus V1 to the power minus 1 minus C plus V2 C plus V2 into C minus V2 power minus 1 and 0 cancel 0.012 is equal to C. I take C common, I can write it as C into 1 plus V1 upon C into C minus 1 minus V1 upon C minus C. So it is 1 minus V2 plus C. Here C is the speed of sound and into C power minus 1 minus V2 upon C to the power minus 1. These two get cancelled here. So here thing left using binomial expansion. Actually they said that V1 very much less than C V2 similarly. So it is 0.012 is equal to 1 plus V1 upon C into 1 minus plus V1 upon C minus 1 plus V2 upon C or into 1 plus V2 upon C. By using binomial, because V2 and V1 are much less than C, I have used here the formula 1 plus x to the power n is equal to 1 plus nx, and this is to x much less than 1. Since V1 less than Vc, so this thing is less than 1. So now it becomes 1 or plus V1 square upon C1 square or plus V1 upon 2V1 upon C minus 1 or minus V2 square upon C square or plus 2V2 upon C. चूंकि V1 V2 less than C है तो these terms are negligible. One cancel, so it becomes here, sorry, minus 2 upon C into V1 minus V2. So that way V1 minus V2 is equal to 0.012 into C upon 2. C is given 330. So 0.006 into 330 meter per second. If we convert that into kilometer per hour, so 0.006 into 330 into meter per second, 10 to the power minus 3 into 3000 by 1 meter upon second है तो मीटर का 10 to the power minus 3 meter 1 second 1 upon 3000 second hour. So when we solve it, so this is 0.006330 or into 3.6. 0 6 से 18 decimal after 3 into 3.6. Yes, it is nearly 2 to nearly 7 kilometer per hour will be with this speed. This question has been asked 2010. You may be disturbed here. Actually, I have taken denominator into numerator and taken C common because I want to apply this formula. I hope you will enjoy this question. I will take some more questions. So please learn these questions properly. Please like the video, share the video, ask your friend. Dear student, I have completed the syllabus of class 11-12. In class 12 actually the syllabus has been deleted in semiconductor and that is syllabus there is up to use of diode only rectifier. But I may tell you about something more about conductors, and I have told many things about other diodes, like Zener diode, like LED, like solar cell, etc., photo optic diode, etc. Please see them for your knowledge, for your curiosity to know about what is happening in semiconductor. So I have done this and will be telling later on. Thank you.